In this episode of Mrs. Fluegel Presents, we're going to talk about electrical circuits. In our previous lesson, we learned that circuits are a closed path that electric current follows. So here we have our battery, just like last time. We have a positive end and a negative end, and we're going to connect some wires from that negative end to a light bulb, and then from that light bulb to the positive end of our battery. And as we connect those wires, our light bulb is going to turn on. When we draw out circuits, we use certain symbols. For example, the wire in a circuit is represented by a solid line. A switch is represented by two dots. And if it's closed, there's a line connecting those two dots. And if it's open, the line between those two dots is not connected. A light bulb in the circuit drawings is represented by a picture of a light bulb inside a circuit between the wires, and a battery is represented by lines with two poles at the end. If we go back to our original circuit, we have our battery and our light bulb. Okay, so we're going to draw the simple circuit. So we have our light bulb, and then we're going to attach the wires, and they're going to come down, and we're going to draw the battery, which are those four lines, and then we're going to connect the wires back up to the light bulb. So that is a simple circuit. But did you know that there are different kinds of circuits? The first type of circuit that we're going to talk about is a series circuit. This series circuit has current that only has one loop to flow through at a time. So here's a battery, and we're going to have two lights that we want to connect in a series circuit. And so we're going to draw the wires so that that wire is completed in one loop that connects to that battery. So what kinds of materials contain series circuits? Series circuits are found in Christmas lights, and they're also found in flashlights. The next kind of circuit that I'd like to talk about is a parallel circuit. A parallel circuit contains two or more branches for the current to flow through. For example, we have these two lights here that we want to connect to that battery again, but we're going to connect them a little differently. You'll see that we're going to have two branches that come off of that main wire to connect those light bulbs to. And so then we'll complete the circuit by attaching it back to the battery. And now we have a completed parallel circuit. So what kind of materials contain parallel circuits? Houses are one of the main things that contain parallel circuits. Our cars also contain parallel circuits. So now we've talked about series and parallel circuits. Can the two ever be combined? Yes. A complex circuit is a circuit composed of both series and parallel circuits. We're going to draw a simple circuit here again. We're going to have our light bulb, and we're going to connect those wires to our batteries, and our light bulb comes on. Now we're going to add a parallel circuit where we're also going to attach two light bulbs in series. And as we attach the wires to those light bulbs will come on. So now that we know about circuits, how can we get electricity into our homes safely? Because overheated circuits can cause fires. Electrical energy enters our homes at the circuit breaker or fuse box. It then branches out to appliances, wall sockets, and lights. So, how does a circuit breaker work? There's a bunch of different circuit breakers in our circuit boxes. And so a circuit breaker is a small piece of metal that bends when it gets hot and opens the circuit and stops the current flow. We often call this popping a breaker because we'll hear an audible pop when it turns off. The good thing about circuit breakers is that we can turn them back on when they cool down. Is a circuit breaker the same as a fuse? Actually, it's not. An electronic fuse is a small piece of metal that melts if current becomes too high, opening the circuit. So when you break a fuse, you aren't able to turn it back on again. You have to replace that fuse. So remember, the next time that you turn on a light in your house, how much work has gone in to design the circuits to make everything work properly and to keep our homes safe. I hope that you've enjoyed this video. Please watch my other videos if you have more questions about science topics.